Hi one and all, and welcome to today's video on distance and midpoints. The excitement doesn't start again. If you're new to the channel, it's really good to see you. If you're an old hand, also good to see you. Thanks for sticking with me. If you're new, can you do me a favor? There is a red arrow over there that basically says show me you're watching. That's also a way of supporting by subscribing to my YouTube channel. The reason I'm doing this is realistically for you guys, and it's really nice to know you're out there watching and in fact enjoying the video. So if you are, leave a comment below. If there's anything you think I can do better, leave a comment below. But otherwise, let's get into this fabulously exciting distance and midpoints video. Now, by the end of the lesson, as I normally say, we've got some learning happening above me. Basically, know what it means by the term midpoint, know how to find the midpoint of line segments that are parallel and non-parallel to axes, and know how to find the distance between 2 points. Now, you're probably going to go, hold on a moment, this all sounds wildly familiar, finding the distance between 2 points. If you think you've got issues, I swear I've recorded this video before, at least 27 times. I honestly, I am absolutely adamant I've done this before. But maybe it's because in maths, what we find is a lot of the content is relatively repetitive. And we seem to repeat it over and over and over again each year level. So by the fact that we're doing this in methods 1 and 2, I can promise you're going to recap it again in methods 3 and 4. So I'm going to try and make this relatively quick. Now you're sitting there going, what's this methods 1 and 2? I'm in the UK, I'm in Australia, I'm in India. Don't worry about it, it's fine. Maths is universal. It's just, I'm a teacher, I'm teaching kids. Hi guys, and effectively just doing my best to follow a scheme of work and a syllabus that's been laid down here in Australia. Yes, no one speaks like that really. Now there's not much of a recap to do, so I'm going to go straight into 2 points in a Cartesian plane. What's a Cartesian plane? Set of axes. And do you notice that language in maths, so bloody irritating. Yeah, I swear we choose about 15 things to mean all the same thing, like sum and add and all those type of things, and plus, oh, Barry. Anyway, new discussion. So looking at these 2 points, I have the point 2, minus 2, comma 2, and I have the point 2, comma 5. Now, those points are brilliant because when I have 2 points on a line, or that way for the camera, then I can draw a straight line between them. Yay! And then drawing 2 points between them, what do I notice? Well, I notice I've got a slanted line, a diagonal line, a line that's sort of got a, oh, hold on, a gradient. Or, more importantly, could be part of a, oh, I don't know, a right angle triangle. So the first thing I do is normally write down the 2 points, and I'll explain why in a moment, but I also draw a quick right angle triangle. And the reason I'm going to draw a right angle triangle is minus 2, 2, and then 2, comma 5. Because when I see a right angle triangle, I know from year 9 and year 10, I have Pythag and trig. Well, what's Pythagoras theorem? Pythagoras theorem is finding the missing length of a side of a right angle triangle. Well, to try and find the missing length of this side, I'm going to turn this into my right angle triangle. So all I've done is made that a right angle triangle. And the distance between those 2 points, sorry, that way for the camera, always reverse it. The distance between those 2 points is actually just part of Pythagoras theorem. So if I can find the distance here, and I can find the distance here, then I can use Pythag to find the distance there. Now, how on earth am I going to find the distance horizontally? Well, they've given you that information because an x-coordinate is nothing more than a distance away from the origin. So we know for this coordinate here, it's minus 2 away, so it's 2 lower than the origin, and this one here is 2 higher than the origin. So if I look at the gap between those two, from minus 2 to 2 is 4. So that's 4 units. Now, it's very much units, it's not centimeters, because a Cartesian plane doesn't have a specific length. You know, because we know we're dealing with coordinates, we know we're dealing with units. So I've got my horizontal distance. How do I find my vertical distance? Well, the same way. A coordinate is nothing more than code for a distance. So this seems to start at a horizontal distance 2 above the line, or the x-axis finishes at 5 above the line and has a distance of 3. And so what do we do? Well, there we go. I now know I've got Pythagoras theorem. So I'm going to call that x, which is my distance between. And I'm going to say, well, then x squared must be equal 3 squared plus 4 squared, and it just so happens, oops, no, try that one again. It just so happens that I've chosen beautiful numbers to make this all work fabulously. So x squared is 25, so x must be equal to plus or minus the square root of 25. And you want to say, why on earth have you written that line? At this moment in time, I'm writing the line so that it just sort of makes sense. So x is equal to plus or minus 5. Now remember, when you square root something, there are always two values. If you have x to the power of 4, x to the power of 6, x to the power of 8, there are always going to be more than one solution. Yes, so there'll be a positive and a negative. Now we come on to that way more later in the course, but now I need to think about my answer. I haven't got that plus and a minus. I need to say, well, can I have a negative distance? No, I can't. So therefore, I know that the length of the line segment would equal 5 units. Yeah, so we now know that distance there is 5 units. And that really is the basis for this whole video. There's nothing more really about it than that, other than finding the midpoint, obviously. So wherever you have two coordinates, draw a right angle triangle, use a bit of Pythag, and you're done. Now, they're not always going to give you a graph. It doesn't matter. Draw a quick sketch. Life is good. So that was Pythag. Then we're going to find the midpoint of a line segment. Well, as it says, what does midpoint mean? The middle point, halfway between. And in a way, that's the trick to be able to do this. We want to know what is halfway between. So starting with something relatively simple, we have 2 points here on the same horizontal line. We're starting at minus 3, 5, and we're ending at 2, 5. Well, the 5 at the end of my coordinate just says it's at the same height. So that's all right. Thank you very much. But what about the horizontal distance? How do I find halfway between? Well, there's two ways of doing it. I can draw a line between the two of them. I can whip out my ruler and I can do a little mark halfway between them, and life is good. But wow, I think we're probably beyond that. Actually, 7 and 8. How else can I do it? Well, I can say, oh, well, how do I go halfway between minus 3 and 2? Well, that's the point. I want halfway between minus 3 and 2. And the easiest way to find the midpoint of any two numbers is add them together and divide by 2. All right? So literally add them together and divide by 2. So minus 3 plus 2 divided by 2, which will give me minus 1/2. So you're going to turn around and say, well, what does this minus half mean? Well, because we're dealing with coordinates and we're dealing with Cartesian planes, our midpoint has got to be expressed as a coordinate. So all I now know is that my x value is minus 1/2. But what about my y value? Well, because it's a straight line, if it starts at 5 and ends at 5 in terms of a y-axis coordinate, same thing. So therefore, the midpoint here is going to be equal to minus 1/2, 5. Yay! With methods and any subject, please remember that when you are dealing with coordinates, express your answer in coordinates. So midpoints, always coordinates. Length of lines, obviously not a coordinate because it's a length, but it must be expressed in terms of units. So here we go. Now we've got a vertical line. So if I draw a thing here, that was not a straight line at all. That is shonky. Word of the day. Love shonky. Basically, long story short, now because it's a vertical line, what I'm going to do is notice that my x coordinates are the same. So I know that my midpoint is going to start with 2, he says writing it as a 2, all I've got to do is find the midpoint between 5 and minus 2. Well, the same thing. So I do 5 plus minus 2 divided by 2. Easiest way to find the middle of 2 points, add them together and halve them. So 5 plus minus 2 is going to give me 3, 3 on 2. So I'm not going to leave my coordinate as that. It makes no real sense in methods to write things as 1.5 or 1.67 unless the question tells you to do so. So where possible, we always try and leave our answers in exact values, which are fractions and anything that can be written as a whole number or something in a nice form. Then we get to this point here. Whoa, life is exciting. I'm going to go back to that original question. How do I find my midpoint? Well, once again, I'm going to draw them together. Now, the midpoint is literally the middle point. It's halfway between. And the way we get halfway between is we find halfway across the horizontal and halfway across the vertical. And it is actually that simple. So if I look across here, and here is my right angle triangle. So I now know that I've got my coordinates points as minus 2, 2, and 2, 5. So the first thing I need to do is find halfway across horizontally. Well, I know my horizontal coordinates start at -2 and finish at 2. So I'm now going to do minus 2 plus 2 and halve it. I'm going to take my 2x coordinates and halve it because I know it's going to be halfway across there. And what do you think I'm going to do for my y coordinates? Well, exactly the same. Yes. So I'm going to take my 2, I'm going to add it to my 5, and once again, I'm going to divide it by 2. So what does that give me? Well, minus 2 plus 2 is 0, divided by 2 is going to give me 0. Thank you very much. And 2 plus 5 is 7, divided by 2 is just going to be 7 on 2. And ladies and gentlemen, if I was to plot that, which is 0, 3.5, that is roughly speaking here. And because my graph sketching on here could be a bit better, I can guarantee you if we went back and drew that properly, it would go through 0 and 7 on 2. So again, the midpoint of the line is just, if you've got the 2 points, just halfway that way, and there's your midpoint. Now, unfortunately, Barry, being Barry, is just evil, and as such is like, oh, no, we're at methods 1 and 2 now. Let's throw in really incomprehensible formulas. And so in your textbook, or I don't know, your teacher may turn around and say, well, this is the formula for the distance, and this is the formula for the midpoint. Well, if we start at that midpoint, it sort of looks familiar. It says do an x1 plus an x2 and divide by 2, and a y1 plus a y2 and divide by 2. Well, what's that all about? Well, not all coordinates will be expressed. That was a dreadful triangle as well. Let's put the right angle in terms of numbers. So what we can do is we can express this coordinate here as x1, comma y1. Now obviously those ones and commas become challenging, and this coordinate here becomes x2, comma y2. So if we take the general case of a coordinate x1, y1, and x2, y2, then suddenly what we're now saying is, well, if we're going to add my midpoint, I'm going to find my midpoint, I need to go halfway across here. So there's x1 and x2. I'm just adding my two x values together. In this situation, they're called x1 and x2. Add them together and divide by 2. Oh yeah, same here, y1 and y2, halfway, add the two together, y1 plus y2, and divide it by 2. So what about this distance formula? I've got square roots and squares. Well, funnily enough, if I go back to my Pythagoras theorem and write a squared is equal to b squared plus c squared, for example, then that could be expressed as a is equal to b squared plus c squared, or the square root of b squared plus c squared. Oh, there's my square root and squared, but what about this b and c? Well, we know b in this situation may be this distance here. And c may be this distance here. Well, how do I find the distance if I've got general formulas? Ah, well, I just do my y2 minus y1 here, and this is my x2 minus my x1 there. So substituting those in, a becomes equal to, well, b now we can write down as x2 minus x1 all squared, plus c we can write as y2 minus y1 all squared, and finish it off with the square root sign. And lo and behold, if we say that a is distance, there's my formula. Now, if I'm honest with you, I never remember the formulas. I know they exist, and if I had to push come to shove, had to use them. But to me, it's just easier to draw two dots, right angle triangle, and off we go. Now, obviously, lots of the questions you're going to end up doing are going to look like this. Find the midpoint and distance of the line segment, join the points a, 1, 5, and b, -2, -3. And you're going to go, oh, do I have to draw a right angle triangle there? You can do, so let me see if I drew a very quick Cartesian plane. 1, 5 is going to be about here, -2, -3 is going to be about here. There we go, so we've got -2, -3, and I've got 1, 5. There's my right angle triangle, and off we go. I can do that, that's fine. Alternatively, I can just say, well, I know that I've got my coordinates 1, 5, and I've got -2, -3. So this is x1, y1, and this is x2, y2. Well, the first thing we're going to do is find the midpoint. How do I do that? I take my two x values, add them together, and halve them. So writing MP for midpoint, I'm going to do 1 plus -2 divided by 2. And how do I find the midpoint of my y values? Add them together and halve them again. So 5 plus -3 all divided by 2. Yeah, now obviously those minus signs are critically important. So we get 1 minus 2 is -1. So that's going to give me -1/2. And 5 plus -3 is going to give me 2 divided by 2 is 1. And lo and behold, there is my midpoint. I didn't really need to draw that diagram, but it didn't hurt. Some people might like to do it. Now what I've got to do, I've got to find my distance of the line segment. So I'm trying to find the distance between those 2 points. So scrolling over so I can keep the question on. What do I know? Well, I know that if we have my right angle triangle, what do I need to know? I need to know that distance there. Well, how do I find that distance there? I need to do the distance between what is effectively 1 and -2. So the distance between 1 and -2 is 3 units. I'm just using my head for that. I know it's 3 units. And what about the distance between 5 and -3? Well, 5 above, 3 below gives me a distance of 8. And I have now everything I absolutely need just by thinking about those coordinates and drawing a quick right angle triangle. So here's my x. So x squared is equal to 8 squared plus 3 squared x is equal to 64 plus 9, so x becomes equal, x squared, bad notation, 73, so x becomes equal to plus or minus the square root of 73, or just root 73. Now if I could, I would try and write that in simplified surd form. But as it stands, I'm fairly sure that I can't divide 73 by any square number to allow me to go down. And there we go, ladies and gentlemen. I can promise you, nothing in the exercise in the Cambridge Essentials textbook series is actually going to be any more complicated than that. It'll throw in some different language, it will try and trick you, but I promise you, that is it. And that, ladies and gentlemen, is about finding the distance and midpoint between lines. Thank you very much for watching. Always good to see you. Now, if you haven't already done so, can you tell absolutely everybody you know about my channel? Small person trying to do big job. Yes, I know, I'm trying on my own, just me, literally just me. So any help you can give would be greatly appreciated. Oh, you want to give help? Thank you. There's a button for you to click. Otherwise, loading on the other side is another video, more maths fun of the same level. It's been good seeing you. Thanks very much. Take care. MaffsGuru out.